7.3, proving triangles are similar. To start this section, we have 3 different ways of proving triangles are similar. The first one being the angle-angle similarity postulate. You can see the abbreviation that we use. If 2 angles of one triangle are congruent to 2 angles of another, so let's say we have angle T congruent to angle P and angle R congruent to angle L, please add those in your picture. This allows us to say the triangles are similar. That's because we had a theorem earlier in the year that said if 2 angles in one triangle are congruent to 2 angles in another triangle, the third angles have to be congruent. Well, if all 3 angles are congruent, all 3 pairs of angles are congruent, that ensures that we have the same shape, so we could say those are similar. The second way, before we move that, we have to write a similarity statement for these 2 triangles. Remember, a similarity statement is just like a congruence statement. So triangle, whatever we decide to name this first one, let's say we use RTS. Now we use the similar symbol, and then we have to make sure we match up the order of the vertices so that the congruent angles are in the same order. So this second one would have to be triangle LPM. The second way of proving triangles are similar is the side angle side similarity theorem. So this is similar to, but not the same as, the side angle side congruence that we've used in the past. Again, you see your abbreviation. So here, if we know we have an angle of one triangle is congruent to an angle of a second triangle, the sides including those 2 angles, that's the key. The angle has to be the included angle. If those sides are proportional, then the triangles are similar. Then your third way is the side-side similarity theorem. So your abbreviation again. And this says if the corresponding sides of 2 triangles are proportional, meaning all 3 pairs of them, then the triangles are similar. So in the number 4 here, we've got 5 different sets of triangles. We have to explain why they are similar, and we have to write a similarity statement. So the first thing I would recommend you start out doing is looking for angles that you know are congruent. So in the first one, we've got 2 45-degree angles, 1 in each, so we know those are going to be congruent. We also have to recognize the vertical angles, which we know are always congruent by the vertical angle theorem. So now I have 2 pairs of angles that are congruent. These are similar triangles by angle-angle similarity. Writing a similarity statement. In this case, I wrote triangle WRS is similar to triangle BVS. Keep in mind that your similarity statements do not have to be the exact same as mine. As long as your corresponding vertices are in matching order, you should be okay. Let's move over to the one on the right. Again, I recommend you look for angles that you know are congruent first. So in this case, we've got a pair of vertical angles we can say are congruent. And then we don't have any more angles we can say are congruent because we do not know if we have parallel sides. Some people make that assumption. Be careful that you don't do that. We need to look at sides being proportional or not. So I could do the 18 over the 24 and 12 over the 36 and check those. Or I could do the combination of 18 over 36, 12 over 24, which in that case, if I did 18 over 36 and 12 over 24, they both would reduce to be 1/2. 1/2 ends up being the similarity ratio. So those sides are proportional since they both reduce to be the same ratio. If you notice, or if we would have attempted the 18 over the 24 and the 12 over 36, those wouldn't have been able to be reduced to be the same ratio. So we just need to try another combination then. And once we've tried all the combinations, then if none of them work, we would be able to say that they're not similar. So now if these are similar and they have a similarity ratio, those 2 sets of sides are proportional, we would be able to use side angle side similarity for this pair of triangles. And then a similarity statement, would be triangle ZVY is congruent to triangle XVW. All right, if we move down to the second row, here we have some information that's given to us but not shown in the picture. So segment MX is perpendicular to segment AB. We should make sure we include that information in the picture. So we know that these are both right angles by the definition of perpendicular lines. And then those are also going to be always be congruent. There's a theorem that tells us that. 58 is congruent to 58. We are able to use angle similarity. And a similarity statement here. Triangle MAX similar to triangle KBX. Moving over to the right, this pair of triangles, we do not know any angles are congruent between the two triangles. We would be able to say angle B and angle A in the first triangle on the left are congruent by the isosceles triangle theorem, and that angle E and angle F are congruent in the triangle on the right, again by the isosceles triangle theorem. But that does not mean they are congruent to each other. There's nothing that tells us that angle B is congruent to angle E or anything like that. So we cannot make that assumption. What we have to do, since we have all three sides of each, is we have to set up our extended proportion, 6/8, 6/8, and 9/12, and those all reduce to 3/4, so that's our similarity ratio. Since they all reduce to the same ratio, and we're able to find that similarity ratio, all three pairs of sides are proportional, so we're using side similarity for this one. And a similarity statement would be triangle ABC similar to triangle EFG. Our last pair here at the bottom. Which method of proving triangles similar would we use here? So we know we have right angles. We know those are congruent. Now we have to check sides because we don't know any other angles. So I set up the proportion 8/6 equals 4/3. Those both would reduce to be 4/3. So that's our similarity ratio. In this case, we are using side angle side similarity. And an example of a similarity statement that you could write would be triangle XYZ is similar to triangle QRP. On the back of the notes, we have different problems where we need to find certain values within some triangles. The first thing you have to think about is whether or not the triangles are similar. And if they are similar, how are they similar? You have to be able to tell me so that you can use, so that you'd be able to move forward. All right, so for number 5, how are those triangles similar? So in this set of triangles, again, first thing I always look for are congruent angles. So we know that we have vertical angles that are always going to be congruent here. Now I don't know any more angles, so I have to start looking at sides and whether or not they are proportional. So the first thing that I might try is 12/24 and 16/8. When I reduce both of those, you notice they do not reduce to be the same thing. So I need to try another combination of those sides to see if those would be proportional. When we take 12/18 and 16/24, those both reduce to 2/3, which means we can use side angle side similarity for these triangles. And that also tells us our similarity ratio is 2:3. So we use that similarity ratio to set up a proportion in order to solve. If we're supposed to find DE, somebody might choose to put a variable for that length in the picture. And then set up your proportion. You take your similarity ratio. I always suggest using the similarity ratio because it's already been reduced. Your numbers will be smaller and easier to deal with. And in this case, we went from triangle ABC to triangle EBD. So we need to make sure we keep that order in our proportion. So we'd have to have 10/x, smaller to bigger if you'd prefer that. Now cross multiply and solve, you'd end up that x equals 15. Now I am kind of particular about how your answer is. If I ask you for the length of DE, that's how your answer should be given. The length of DE is equal to 15, not x equals 15. In number 6, we're given this quadrilateral ABCD and told that it is a parallelogram. Our job is to find the length of WY. So again, the first question is, are those triangles similar that you see? And if so, how? So I'll tell you right now, they do end up being similar. For what reason? What way are we able to use to show that we have two similar triangles? So here we'd be using angle-angle similarity because we've got some alternate interior angles, and if all you noticed were those angles, that would be fine because you've got your two there. Or you could notice that you have vertical angles that are congruent as well. So any two pairs is all you need, so you'd be able to use angle-angle similarity. And here's my variable that I'm going to solve for, length of wy. So now I need to look at what my similarity ratio would be. Now here it could be kind of tricky because you got to make sure you are comparing corresponding sides and using them to set up your similarity ratio. So notice the 5 is between the angle that I have marked with 1 congruent arc and the 3 congruent arcs. That's the piece I'm trying to find with the x. I don't know what that value is. So those are the two that have to go in the same ratio, which means the 4 and the 10 have to go in the same ratio within the proportion. So here is a proportion you'd be able to write. 5 over x equals 4 over 10. If you want to write 2/5 instead of 4 over 10, you're using the reduced similarity ratio. That would be fine. Now you cross multiply and solve. You get x equals 12.5. Again, make sure your answer is written as it should be. You get length of wy equals 12.5. In number 7, you have two triangles in this. They're just overlapping triangles in this case. So now, which method is used to prove these triangles are congruent? Not congruent, I'm sorry, similar. So the first thing we need to be able to notice is that we have a shared angle. So we know that's going to be congruent in both triangles. And what you need to be careful of here is you've got a small triangle and a big triangle. So sometimes people will make mistakes on this because they don't use a full length of the big side of the triangle. Can definitely cause some issues. So that I only have one pair of angles congruent, I need to start comparing sides now. So the left side of the picture, the small triangle has a length of 12. The big triangle has a length of 20. You need to make sure that you use the entire length of that large triangle. The right side would give me 15 over 25. So those both reduce to 3/5 so that I have my similarity ratio, meaning side angle side similarity says that these are similar triangles. Now the proportion that I would set up for this, now since I have a similarity ratio, I would use that similarity ratio, just deal with smaller numbers. So I'm going to stay with the small over big. 3 over 5 is small over big, which means with the piece that I'm trying to solve for, that's a part of the big triangle that needs to be in the denominator of its ratio within that proportion. If I cross multiply and solve, I would find that x equals 85 thirds. I would just leave it as 85 thirds. You don't need to round it then. It's more accurate. And since you're just told to solve for x, you would not have to write your answer differently like we did in 5 and 6. So what's the point of these similar triangles? Well, these are used in something called indirect measurement, when you're trying to find lengths or distances that are difficult to measure with the way that you typically think of measuring something using a ruler or a tape measure or something like that. Now, I understand there's technology these days that'll do this for us, but this is where everything is based off of. This is what used to be done on a regular basis. So here you have an example of indirect measurement. It talks about Ramon placing a mirror on the ground. The mirror is here at point M. 40.5 feet from the base of a geyser. He walks backwards so he can see the top of the geyser in the mirror. His eyes are 6 feet above the ground. He's 7 feet away from the mirror. So we have to use similar triangles here to find the height of the geyser. First thing I would do is I would label all the sides and all the information that I know. Oops. There we go. We'll come to that in a minute. So if I have everything labeled here, we need to figure out why are these triangles similar. So we have these terms, angle of reflection, angle of incidence. The angle of reflection and the angle of incidence, they look like they might be vertical angles, but they're not because they're not formed by just two straight lines. The important part about angle of reflection and angle of incidence, and maybe you've learned this in science, is that these are always equal to each other. They're always congruent. So in situations like this, we are using angle-angle similarity because we have right angles, because things stand up straight off of the ground, for our purposes at least. So if we set up a proportion, we would be able to take 6 over x, so I'm going small triangle to big triangle, equals 7 over 40.5. Now in this case, you would give me a decimal answer because it's asking for a specific height of a geyser in this case. You wouldn't generally give an answer of 243 over 7 feet for that. You'd round it off. And notice again the label. You need to make sure you have a label for your answer. All right, last thing here. Oops. I'd like you to do number 9 on your own. First question about number 9 is why are those triangles similar? And then go ahead and solve for the height of the cactus. So the reason these are similar is using the angle-angle similarity. So we are going to say that both the person and the cactus are making a right angle with the ground. And then we would also have congruent angles at the bottom right corner of each triangle. And realistically, you'd have congruent angles at the top of the cactus and coming off the top of this person's head, the angle that the sun is hitting it. Those would also be congruent. So any two pairs of angles you look at, you'd have angle-angle similarity being able to be used. So now find the height of that cactus. The height of that cactus would end up being 13.5 feet. Make sure, again, you have your label.